Okay, this is section 1.3. Here we're going to be dealing with linear functions. Um, so we're going to have to talk about slope and also y-intercepts, and we'll do a little bit of maybe an application of a linear function. Okay, so let's get going. So linear functions, they're of the form f of x equals mx plus b. And remember here that we could just replace f of x with y. So y equals mx plus b. It's the same thing. It's a function. It passes the vertical line test. Okay, so let's define a few things here. Let's begin by talking about this value m. So we have y equals mx plus b. Let's first deal with m. M is called the slope, and we'll talk a little bit more about it here in a second. Right now I'm just going to tell you that it's called rise over run. So the change in y over the change in x. If you give me 2 points, if you give me the point x1, y1 and the point x2, y2, then I can compute the slope by forming this fraction. So it's the difference in the y's. So this y coordinate minus this y coordinate, y2 minus y1, divided by the difference in the x's. This x coordinate minus this x coordinate. So that's the m. What the m tells us about the line is the steepness and the orientation of the line. How steep is the line? Does it go from the bottom left to the top right? Or does it go from the top right to the bottom left? So that's what I mean by orientations. That's what this value m is going to tell us. The steepness of the line and the orientation of the line. Now there's this value b. B, turns out, tells us what the y-intercept is. So the y-intercept is a point on the y-axis. It's the point on the y-axis where the line touches the y-axis. And so it's an order pair. It has an x-coordinate and a y-coordinate. Since it's a point on the y-axis, its x-coordinate is 0. So think of the y-intercept as a point, 0, b. It's not just b. B is not even a point. You need an order pair in order to represent a point. So the point is 0, b. Okay, what's a constant function? What's a constant function? Well, a constant function is a function that doesn't change. It's always the same value. So imagine so that, for instance, if remember x is the independent variable, y is the dependent variable, and so I make a choice of x, and that gives me a y. So imagine that my x is 1 and my y is 3. My x is 2 and my y is still 3. My x is 3, my y is 3. My x is 4, my y is still 4. So that's a constant function. The y value is always constant, no matter what x you choose. So an example of a constant function is something like y equals c, where c is any real number. A concrete example would be something like y equals 3. That's just a constant function. It doesn't matter what value of x you throw at it, it's always the same y value. It's always constant. Now there's this thing called the identity function. The identity function is y equals x. And that'll come in handy for us later on when we talk about composition of functions. This function right here sort of almost acts like, well, I guess I want to say like a multiplicative identity, whatever that means. But this is an important function, y equals x. We'll talk about it further down the line when we talk about composition of functions. Horizontal lines. Well, it turns out that horizontal lines are the same thing as constant functions. Horizontal lines and constant functions are the same thing. So yeah, I mean, it's just a function. It's just a horizontal line. It's just a horizontal line. There's no change in the y value, no matter what x you throw at it. So constant functions and horizontal lines, you can think of them as the same thing. Now, vertical lines. Vertical lines are a little bit different. The equation for a vertical line is x equals some number c, some real number c. So x equals. Turns out that these guys are not functions. So let's kind of mention that. These are not functions. Why? Because if you think about it, they failed the vertical line test. It's a vertical line itself. So these are not functions. Their equations are x equals some real number. So for example, x equals 5. That's an example of a vertical line. So keep vertical lines and horizontal lines, keep the difference in mind. For horizontal lines, it's y equals some real number. For vertical lines, it's x equals some real number. Okay, so let's move on. Let's talk a little bit about this slope, this business of slope. So we said that it's called m. It's also rise over run. And here, what this means right here is this is the change in y divided by the change in x. So that's how you, these little triangles, it's actually called delta, but you might see that once you get into Calc 1. So this is change in y, that's how you read it, over change in x. Okay. Now, if you give me 2 points, if you give me the point x1, y1, and another point x2, y2, I can compute the slope by forming this fraction. So it's the change in the y's in the numerator. So the difference in the y coordinates, y2 minus y1, divided by the change in the x coordinates, the change in x, so x2 minus x1. And it's the same thing as if you did y1 minus y2 divided over x1 minus x2. Just be consistent. Okay, so that's slope. And what does slope help us figure out? Well, as we said earlier, it helps us figure out the steepness of the line. How steep is the line? So if you ignore the sign of the number of the slope, if you just look at the number, if it's a really, really large number, like let's say 722, then that means that your line is very, very steep. It almost looks vertical. Whereas if your slope happens to be something very small, like let's say 0.003, then your line will almost look horizontal. So depending on the number, the larger the number, the steeper the line, the smaller the number, the more horizontal the line gets. And now, let's talk about the sign of the slope. So if my m happens to be positive, then you can think of the line as increasing from bottom left to upper right. Now, if my slope happens to be negative, then your line is sort of decreasing from upper left to bottom right. And by the way, always think of the slope as a fraction. So even let's say your slope was something like, let's say your slope was something, I don't know, let me, over here in the margin. So I'm gonna say think of slope as a fraction. So if your, let's say m was -3, how would you think of that as a fraction? Well, I would just say -3 over 1. Yeah? So always get in the habit of thinking of slope as a fraction. Okay. So positive slope, our lines are increasing, bottom left to upper right. Why is that? Because, well, what's happening is you have positive rise, so positive change in the y's, so that means you're going up, and positive change in the x's, so you're going to the right. So that's what this little plus over plus is saying. So positive over positive. So you go up and then to the right. Whereas over here with negative slope it looks like my line is decreasing from upper left to bottom right. Why is that? Well, because let's say my rise is negative. So from one point I have to go down and then to the right, and then down and then to the right. Now, if you have zero slope, that means that you're dealing with a horizontal line. A horizontal line has slope 0. And a vertical line has undefined slope. So a vertical line, we're going to say that its slope is undefined. So let's see, which of these four examples, so I have a line with positive slope, I have a line with negative slope, I have a line with slope 0, and I have a line with undefined slope. Of those four, which one is a function, which one is not? I'm gonna say, so let's say, let's think about functions. Which ones are functions? I'm gonna say positive slope, negative slope is a function, 0 slope is also a function. Why? Because they pass the vertical line test. This line right here with positive slope, it passes the vertical line test. If I draw vertical lines through it, the vertical lines will touch in only one point. This line with negative slope also passes the vertical line test. This line with 0 slope passes the vertical line test. The one that doesn't pass the vertical line test is the vertical line. So not function. Vertical line or undefined slope. Okay, so hopefully that's okay. Okay, let's get into the nitty-gritty here. Let's try to find the slope of some lines, and let's just practice that first. So in this first exercise, what we were given is 2 points. We were given 2 points. The point negative 12,4 and the point 3, negative 5. And right now, all we have to do is we want to find the slope of the line that would go through these 2 points. And I'll help you with the first one, and then I'll give you a chance to try the other two on your own. Okay, so let's see. I'm going to try to find the slope of this line that happens to go through these points negative 12,4 and 3, negative 5. So I'm going to say m is equal to, and right now, so remember in your numerator, so we're going to form a little fraction, and the numerator of this fraction is going to be the difference in the y's, and the denominator is going to be the difference in the x's. So the numerator is a difference of the y coordinates, the denominator is the difference of the x coordinates. So which one, so what y coordinate minus which one? So it doesn't matter, look. I'm going to do it in 2 ways right now. I'm going to say this. I'm going to say this y, so 4 minus negative 5. So I'm going to say 4 minus negative 5. But then I have to be consistent. So if I chose this y coordinate minus this y coordinate, then I should choose this x coordinate, negative 12, minus this coordinate, 3. So minus 12 minus 3. And now be careful with signs. This becomes 4 plus 5 over, and then negative 12 minus 3 is negative 15. Okay, well that's 9 over negative 15. Or if we reduce this fraction, that becomes 3 over negative 5. Yeah? Now, what would have happened if I chose differently? So I said 4 minus negative 5 divided by negative 12 minus 3. But what if instead I had done negative 5 minus 4 divided by, and again, we gotta be consistent. So if I did negative 5 minus 4, now the denominator should become 3 minus negative 12. Okay, well, negative 5 minus 4, that's negative 9, over, and then this becomes 3 plus 12. Okay, so that becomes negative 9 over 15. Which turns out is also negative 3 over 5. It's the same thing. And now if you're thinking, wait a minute, in the top one, the negative is in the denominator. On the bottom one, the negative is in the numerator. It does not matter. It's the same fraction. So here the thing to kind of keep in mind is the following, that negative 3 over 5 is the same thing as negative 3 over positive 5, which is the same thing as 3 over negative 5. They're all the same fraction. Yeah? It doesn't matter where you apply the negative to. Sometimes you gotta get creative and move the negative from the numerator to the denominator, or vice versa, so that you can do some arithmetic or something. Okay, so that's my slope. It's negative 3/5. Yeah? So if I was to graph the line that goes through these 2 points, I would expect the line to be decreasing from upper right to bottom left. Why? Because my slope is negative. Okay, so pause the video, take a couple of minutes, try to find the slope for these 2 other exercises. So here they give us the little line segment that joins these 2 points, negative 3, 4, and negative 1, negative 2. What's the slope of this line? What's the slope of this other line over here? The one that happens to go through the point negative 5, 0, and 0, negative 3. Okay, so hopefully you pause the video and you actually computed these slopes. So let's just compare answers then. Over here, I'm going to try to figure out the slope. So I'm going to do 4, so it's a fraction again, we said. The numerator is the difference in the y's. It doesn't matter which order you do it, just be consistent. So I'm going to say 4 minus negative 2. So I said this y minus that y, and now since I'm being consistent, I should say this x, negative 3, minus negative 1. Okay, so that becomes 4 plus 2 divided by negative 3 plus 1. Well, that's 6 over negative 2. That's negative 3. Or remember, we want to think about this as a fraction. So let's think about it as negative 3 over 1. Yeah? And so let's see. Let's put our slope to some practice here before we answer the next one. So think about this point, negative 3,4. Yeah, negative 3,4. What the slope is telling me is that there is another point on my line if I go down 3 units, so 1, 2, 3, and then to the right 1, I should find another point on my line. If I keep on going down this pattern, so if I go down 1, 2, 3, and then to the right 1, I should end up in another point on the line. Yeah, that's what my slope is telling me. So the slope in this case is negative 3, or negative 3 over 1. Let's find the slope in this last example. So I'm going to say negative 3 minus 0. So I said this y minus that y. And because I'm consistent, now I should say this x, 0, minus negative 5. Okay, so that becomes negative 3 over positive 5. And that is it. I guess the slope is negative 3/5. Okay, so hopefully you feel comfortable and confident in finding the slope of a line if what you're given is 2 points. All right, let's move on. Let's, I guess, kind of think about some little steps here for graphing a line that's given to you in slope-intercept form. So imagine that you're given some equation. You might be given some equation like this: ax plus by equals c. This is still a line. It's still a line. This is called the standard linear form. Okay, so if you're given a linear equation in this form, in standard form, the first thing you're going to want to do, so step 1, is write the equation in the form y equals mx plus b. So then that means that you're going to have to solve this equation for y. You're going to have to subtract ax, you're going to have to divide by b, you're going to have to solve for y. That's the first step. Once you solve for y, then you can look at what is m and what is b. And remember, you want to think of m as a fraction. You want to think of the slope as a fraction. And also b, you want to think about it as a point. It's a point on the y-axis, so it should be something like 0, b. So since we're trying to graph, in order to graph a line, all we really need is 2 points. More points is good just to kind of make sure things are okay, just for extra, just as a precaution, but it's not necessary. You just need 2 points to graph a line. Well, 1 point is given to you for free, the y-intercept, 0, b, that's given to you. So we just need to create another one. That's where the slope comes in handy. We use the slope, so plot the y-intercept. Now the next thing is we use the slope to generate another point. They say here at least 3, but we really just need another one. And so the slope is rise over run. If you have positive slope, your line should be increasing. You go up and then to the right, so things are going up. If you have negative slope, you might be having to go down and then to the right. That's why things are going down. Or you might have to go up and then to the left. Things are still going down. Yeah, because remember, if the negative is in the numerator, you can change it to the denominator and it's still the same fraction. Then you connect the points and draw some little arrows at the end of your lines. So this is just kind of a little algorithm on how to draw a graph of a line given any linear equation. Let's put it to use. All right, let's see. We gotta kind of sketch a few graphs here. Let's begin with the first one. I'll help you with the first one, and then you'll try the other ones here. All right, so I'm going to go step by step, but then later on you don't really need to write down the steps. You can just kind of do it as. So let's see. The first thing I want to do is, we said, is solve for y. Okay, well, this one's not too difficult to solve for y. This first one's not too difficult to solve for y. I'm looking at my equation right there. All I have to do is subtract 2x from both sides, and that's it. So then it looks like this. Y equals negative 2x plus 7. I have to do that first. I have to first solve for y so that the equation is in slope-intercept form. Okay, next thing. Let me identify slope. So m in this case, I guess, is negative 2. But remember, we want to think of the slope as a fraction. So it's easy to make any whole number into a fraction by just putting a 1 underneath it. So I'm going to say that this becomes negative 2 over 1. That's my slope. 3. Y-intercept. So the y-intercept in this case is, well, it's this value 7, but it's not 7, it's the point 0, 7. So that's my y-intercept. Okay, and then what did step 4 ask us to do? So step 4 is, well, step 3 is we gotta plot the y-intercept. All right, let's begin by plotting the y-intercept. So 0, 7, that's right there. That's 0, 7. That's my y-intercept. And now I gotta think about the slope. Look, the slope is telling me the numerator is the change in the y. The numerator is the change in the y. The denominator is the change in the x. So right now, my change in y is negative 2. That means that from this point, 0, 7, I have to go down 2. So I have to go 6, 5. And then the denominator is telling me the change in x. It's telling me that it's positive 1. So I go to the right one. So I should have another point right there. And the coordinates of that point should be 1, 5. Okay, let me generate just another point just to make sure that I'm careful here. So I'm going to now go to this point right here, and again I'm going to follow the slope. What the slope tells me is I have to go down 2 units, 1, 2, and then 1 to the right. So that puts me right there. That's the point 2, 3. And I think at this point I'm done. I am ready to finish my line or connect the dots as best as I can. And by the way, so just as I went down 2 and to the right 1, I could have also gone up 2, 1, 2, and to the left 1. And that would have given me this point. Yeah, because remember, you can also think about it as 2 over negative 1. So then you go up 2 and to the left 1. It doesn't matter how you think about it. Alright, so some situation like that. Let me not forget to draw my arrows. And I think that's the line that I'm interested right there. Okay, so what I would do if I was you at this point is I would just pause the video and finish plotting all of these lines. So you have 1, 2, 3, 4, 5, and 6 lines to plot. Try them. Pause the video and try to plot these 6 lines. Some of them are a little bit easier, some of them are a little bit harder. But challenge yourself. Try it. We'll compare answers. Okay, so let's see. Let's graph the next one. I'm not gonna go step by step. Well, I mean, I guess I'll just maybe I will. I don't know. I will go step by step. So I'm gonna do 1. The first thing I gotta do is solve for y. So I wanna say y equals, well, let me solve for y here. I guess the first thing I would have to do here in order to solve for y is I'm going to subtract 4x. So negative 3y equals negative 4x minus, plus 30. So the reason why this is a negative 4x right here is because I subtracted negative 4x from both sides. Yeah? And then the next thing I'm going to do is divide everything by negative 3. So then I'm going to divide everything by negative 3, by negative 3, by negative 3. And that gives me, I guess, what I want. That gives me y equals, and then negative 4 divided by negative 3, well, that becomes positive. So that's 4/3. And then positive 30 divided by negative 3, that becomes negative 10, minus 10. Yeah? So hopefully you agree on what we did here. We just solved for y. That's the first step. Okay, so now I know. It gives me a little bit of information. I know that my slope is 4/3. And I also know that the y-intercept is the point 0, negative 10. Okay, so I think I'm ready to plot this line now. Let me go first to the y-intercept. So I'm going to use the point that was already given to me, 0, negative 10. Okay, well, that's way down here. And then let me pay attention to my slope. My slope is telling me the numerator is the change in y, so I have to go up 4 units, and my denominator is my change in x, so I have to go 3 units to the right. So up 4 units, that puts me at negative 6, and then 3 units to the right. Okay, that's that point right there. And then just to make sure, I'll put another point. So I'm gonna go up 4 from here. 1, 2, 3, 4, and 3 to the right. Okay. Don't forget the little arrows just to indicate that the line sort of keeps on going forever in both directions. And I think that's my line right there. So hopefully you agree with that. Let's see. Let's think about the next example. This one's nice. This one's nice because the next example, because we don't have to solve for y. It was already solved for us. So that's convenient. There's no reason to solve for y anymore. Now, but just be careful here. Which one is my m? Is my m -3 or is my m 1/2? M is always the number that's in front of x. So just be careful there. Just be careful. This might get a little tricky here. So right now what I can conclude is, oops, let me use red, is that m is 1/2 and my y-intercept is the point 0, -3. Yeah, so there was no reason for me to solve for y here. My m is 1/2, my y-intercept is 0, -3. Now let's see if I think I'm in a good position now to plot this. So first let me plot the point 0, -3. So that's right there, that's 0, -3. And now my slope is telling me to go up 1 and to the right 2. So up 1 and to the right 2. And then just to make sure and make my line a little bit more accurate, up 1 and to the right 2. Notice that I could also go down 1 and to the left 2. Because then a negative over a negative would give me something positive. But, okay. So I think that is my little line right there. Hopefully we agree. So let's try the next one. Okay, so this is also good for me. This is already in slope-intercept form. It's already been solved for y. So I don't have to solve for y. It's already been done for me. Great then. I just gotta identify what's the slope. What's the slope? And remember, the slope is always the number that's right, that's the coefficient of your x value, the number that's right next to your x. So in this case, I guess it's just -4. That's my slope. Or if we think about it as a fraction, -4/1. Now, what's my y-intercept? Where does this line hit the y-axis? I don't see any other numbers there. Yeah? Well, technically there is. It's just that people kind of get lazy and don't want to write it all the time, but it's -4x plus 0. Yeah, if you think about it like that, well, yeah, plus 0 doesn't really do anything. It's just the same thing as saying y equals -4x. And so then that hopefully gives you then the clue that the y-intercept then is the point 0, 0. Yeah, so right now my y-intercept is the origin. And according to the slope, I have to go down 4 and to the right 1. Or I could also go up 4 and to the left 1. And what I have is a diagonal line going through the origin with negative slope. Let me see if I can draw this. This one's kind of steep. That's horrible, but you get the idea. You get the idea. Yeah. I managed to not hit 2 of the points that I tried to hit. I should just use a ruler next time. That's okay. All right, the next one. Let's think about this one. In this one, there's a little bit more work involved because we have to definitely solve for y first. So let's begin with that. Let's solve for y. So I'm going to say -2y is equal to 5x plus 10. See, what I did here is I added 5x to both sides, so 5x became positive. Now I'm going to divide by -2. And that should give me what I want. Let's see. So that's going to become y equals 5 over -2x minus 5. Alright, so then that tells me that my slope is 5 over -2 and my y-intercept is 0, -5. So I think I can plot this now. So 0 comma negative 5, that's down here. And the slope is telling me to go up 5 and then to the left 2. So up 5 and to the left 2. Or I could also go down 5 and to the right 2. It doesn't matter. So hopefully we agree on this. Now let me try to do my best here to connect these 3 dots. I make no guarantees. That's better. And that's what I'm dealing with. That's the line that I'm dealing with there. All right, let's move on to the last 2. I think this one's a little bit easier. Y equals negative 3. What type of line is that? Is it horizontal or is it vertical? Well, it turns out that this is a horizontal line. It's a horizontal line that hits the y-axis at negative 3. So that's not too difficult to draw. Let's just sketch it. So 1, 2, 3. Oops. That doesn't look that's not a very pretty line. It's kind of a shaky line, I'm sorry. It's hard to write on the computer screen with a stylus. So that's my line. That's my line. So this is a horizontal line. What is the slope of this line? The slope is 0. Yeah, the slope is 0. Let's do the last one. X equals 5. X equals 5 is a vertical line that hits the x-axis at 5. So let me do my best here to follow the line here. Whoa. That's the waviest line ever, sorry. So this is vertical. And we said that the slope of this line is undefined. Yeah, here the slope is undefined. Okay, so I hope that you're feeling comfortable graphing linear equations. Remember, if you start over here in the standard linear form, the first thing you want to do is solve for y so that you put it in slope-intercept form. Then identify the slope, plot the y-intercept, and then plot another point to use the slope to plot another point. Connect the dots, and don't forget the little arrows. Okay. Let's do two more little exercises in this section, and that will be it for 1.3. There is this word that you're gonna be seeing quite a bit. If your path takes you to Calc 1 and Pre-Calc and Calc 2, you're gonna hear about average rate of change quite a bit, and all it is just slope. It's you can think about it as let's just agree right now that we can think about it as slope. Average rate of change is just slope. Alright, so let's read this little prompt here. So the revenue from display fireworks in the United States increased from 141 million in 1998 to 320 million in 2012. So right now, so there was an increase. So the revenue from fireworks increased from 1998 to 2012. We want to find the slope rounded to the nearest hundredth in revenue from 1998 to 2012. Okay, so I'll give you a chance to try it. Pause the video, see if you can do it on your own, and then let's compare answers. Okay, so I'm going to set this up as 2 points. So right now my points are the following. I have the point 1998, and then I have my, instead of writing a bunch of zeros, I mean I would have to put 141 and then 6 zeros. I'm not gonna do that. I'm just gonna use 141 and then just agree that this 141 is actually counting millions. So I have that point, and then I have the point 2012 320. And so then my slope is going to become, it doesn't matter how we do this. I'm going to say 320 minus 141 over 2012 minus 1998. Now, you could have said 141 minus 320 divided by 1998 minus 2012. You would still get the same answer as we're going to get right now. All right, so let's see. 320 minus 141, that's 179 over 2012 minus 1998, that's 14. And is this evenly divisible? No. So that's it. But we want to round this. Let's see. So we want to round. We're rounding to the nearest hundredth. Right now, my calculator is telling me, I use this little squiggly equal signs because this is an approximation. This is the exact value right here. This is an approximation. This is saying 12.7857, but I need to round to the nearest hundredth. So the nearest hundredth is this 8 right here. So I think I am going to round, I'm going to say, I don't know, 12.79. Yeah, and let's think about what this is saying. So this is saying, let's interpret this. So I'm going to say the following, that since 1998 revenue from fireworks has been increasing at about 12.79 million dollars every year. So 12.79 million dollars a year. That's what the average rate of change is kind of telling me. Yeah. Okay, so hopefully we agree on this problem. Last exercise. So some cable television gives charges $95 for installation, and then they charge you $125 per month for their star plan. Okay, so we want to write an equation that can be used to determine the total cost, and we're going to use function notation, C of t. So think about this notation right here. So the cost depends on time. The input for this function will be time, so t, and t is going to be measured in months. And then we're going to have to use that little function in order to find the total cost for 18 months of service. So pause the video, see if you can come up with the equation on your own, and see if you can answer part B. You're definitely going to want to come up with the correct equation so that you can answer part B. Alright, so let's see. C of t. So right now my variable is no longer x. That's okay. My variable can be called whatever letter you want. I guess I'm using t now. So t is the number of months, and every month they charge me $125. So in 2 months they would charge me $150. In 3 months they would charge me in 1 month it's 125. In 2 months it would be 250. In 3 months it would be 375, and so on and so forth. So I think that can be modeled by this, 125 t. But then there was this initial charge, the $94 installation. That's kind of a constant cost. That was just, that they're gonna charge me that no matter how many months I use this plan. So I think this is my little function right here. 125 would be the slope. 94 would be the y-intercept. Yeah, so it's a linear function. The initial, my y-intercept is 94, and it increases 125 for each month. T is in months. Okay, so now I guess what we gotta do is compute C of 18. Okay, so what is the cost of this plan for 18 months? So 125 times 8, it's 1,000, so $1,094. That's expensive, I think. I don't know. What do I know? Okay, well, that's it for this section. Hopefully you feel comfortable with linear equations now, slope, graphing linear equations, and I'll see you in the next video.